Good afternoon. It's a pleasure to be here. I want to thank the committee members and the judges for giving us the opportunity to share this work with you. I'm Ceren Kolsarici representing my team. I have my colleague Chris Amaral there as well. If there are any difficult questions, Chris has a microphone. I'm going to pass the questions to him. I have a lot to talk about today. Our interventions are quite complex. They are multi-phase, they are longitudinal. In the interest of time, some parts will be quick, but I'm going to make sure I give you a good understanding of what we've done at every phase and the impact at each phase. And we're also going to talk about scalability and transportability towards the end. So I want to start with an impact statement from our partner. Unfortunately, Dayton's not here right now. But he's going to tell a bit about the partner's perception of how things work and the impact of the project.
Hello, everyone. My name is Dayton Jarrett. I am Vice President at Enpro International. We're an energy consulting company based in Canada. Unfortunately, I'm not able to be with you in Sydney, but I wanted to take a moment to make a statement about our joint project. I wholeheartedly endorse this project for the Practice Prize competition. Chris and his team have solved a very challenging multi-stakeholder problem using an innovative multidisciplinary approach that combines artificial intelligence and behavioral insights. We implemented the recommendations from this project and will continue to use their model in the future. The implementation was very easy and it has had a huge impact for our clients in promoting efficient and sustainable energy consumption practices. This project has the potential to revolutionize peak demand curtailment recommendations by leveraging AI-driven data analysis and behavioral nudges to motivate more efficient energy consumption habits. With that being said, I will now pass it on to Chris and his team to discuss the work in more detail. Thank you very much.
So our context is organizational peak energy curtailment. We're all aware in developed countries and all around the world, we've had significant strides in transferring to clean energy sources. Unfortunately, clean energy only works if supply is roughly equal to demand. What happens when demand is significantly higher than supply is that we have to rely on peaking plants, which means we have to use coal and gas and oil, which means we're going to end up with exponentially larger carbon emissions. And if you look at the statistics, the big contributor to the carbon emissions has been the organizations. It's about 66% of the carbon emissions come from organizations. And recently, I've come across the statistics that since 1988, 100 large organizations in the world constitute about 70% of pollution due to energy. Having said that, to resolve this problem, to address this problem, we're going to introduce a multi-stakeholder intervention by an energy consulting company, Enpro. And the management problem is very specific. It is to improve the effectiveness of critical peak pricing. So what is critical peak pricing? It's a dynamic pricing strategy where governments charge extremely high prices to organizations if they contribute to the peak. How it works is there are 8,760 hours in a year, and at the end of every year, the government ranks these hours with respect to their energy usage, energy demand, and they pick the top 5 hours, and they identify those top 5 hours as the peak. Then organizations are charged a wholesale price as well as a global adjustment. You can think of it as a penalty. For instance, if an organization contributed to the peak demand with an amount of 5 megawatts, and in the province, total peak demand was 100,000 megawatts, then in our context in Ontario, in Canada, government multiplies with an adjustment rate $13 billion, and it could cost an organization about $650,000 for that year only. So this is a very challenging problem to solve. Apologies about the fonts. It looked fine on our computer, so hopefully we won't have a lot of issues. It's a very challenging problem to solve because of 3 reasons. Number one, organizations, in our case, Enpro, the energy consulting firm, they need to identify these peaks ex ante before they actually are realized, before the government even identifies them. This is a methodological challenge. Challenge number 2, it's a combination of communications challenge and a methodological challenge. We're focused on organizational behavior shift. It's very different from consumer behavior shift. Organizations have more strict processes, they have shifts that are already pre-assigned, they have commitments in terms of production and operations and so forth, and employee motivations are not necessarily aligned all the time with company motivations. So those bring up communications as well as methodological challenges. And number 3, we're looking at a long-term behavioral shift. So we're not really interested in a one-time shift, which means we have to take care of compliance. So if there are any false negatives or there are any false positives where the company either misses a shift or they are informed that there's going to be a peak, but there wasn't a peak, this would certainly impact their compliance, so the long-term behavior will be hurt. So we're going to use false alarms and false positives as well in terms of KPIs for our model. This is a multi-stakeholder problem. We're looking at governments or policymakers who introduce the critical peak pricing policy. We're looking at organizations, the clients, who are mostly financially driven, but some of them are maybe altruistically driven as well. They want to decrease their peak energy demand. And we have the energy consulting firms hired by the clients, the organizations, whose mandate is to inform these organizations for when they should curtail and how they should curtail. And finally, we have us, everyone, the individuals and the environment that's impacted by this problem. We're going to introduce a multi-stakeholder intervention. As I've mentioned, this is the framework. The framework is quite simple. We're going to focus on 2 different policy tools. First one is critical peak pricing, but we're going to use advanced AI to increase the predictive performance of these peaks 24 hours ahead. So we're going to forecast hourly energy demand 24 hours ahead. So this is a really long enough window, and it is a methodologically big challenge. Second, we're going to introduce behavioral nudging to improve the communications of the curtailment notice and target the communications-related problems as well. How are we going to execute this? We're going to use a multi-phase longitudinal field experiment. So our manipulations are using advanced AI, which happens in the phase 2, and using behavioral nudging, which happens in the phase 3. And in phase 1, we just want to understand the basic effect of using just machine learning or artificial intelligence to predict the peaks at some competency and inform the organizational clients and see if they have any change at all in their energy consumption behavior. So I will call this the baseline AI effect. Phase 2, we're improving the baseline using advanced artificial intelligence. And phase 3, we're improving that using improved communications. So what I want to show you at the end is how much each part contributes to the overall savings. So essentially, we're going to break down the overall effect into the nudging effect and the advanced AI effect and the baseline AI effect. The output is a scalable, transportable, multidisciplinary framework that accomplishes long-term behavioral change. Our context is reduction in carbon emissions, but I'll show you that we can actually implement the same framework in very different sectors and industries. So we've seen it's a complex problem to solve. Just one slide, I'm going to show you it's an important problem to solve. 2023 has been a terrible year in terms of indicators that relate to global climate crisis. And the last 3-4 years, very reputable scientific journals, as well as policymakers, they started talking about catastrophic consequences of climate change. They talk about extinction of certain mammal species and even human extinction. So it's a very serious and relevant problem to address and think about together. Let's start with the data. We have, and Pro has, 25 of Canada's largest organizations among their clients. We have access to 39 locations of these clients. They span 9 industries. We have organizational level data. We know how long they have been working with the company. We know how big are the locations, how much energy they consume on a regular basis. We know if they have generators versus not. Our key dependent variable is their hourly energy consumption. So we have that data per client. But we also have provincial energy consumption and temperatures in the province as well. It's important to be able to calculate the contribution, which will then reflect in the overall penalty each organization is charged. Having said that, let's look at the part 1, the baseline AI effect. I'm showing you 2 graphs here. The top one we split it into 2 because there's a significant difference between companies with generators and without generators. So what's happening here is you have the black lines, which show the business as usual days. So they don't get a curtailment notice, they just consume energy as usual. And the green lines are when they get the curtailment notice that day. You see a significant drop in energy consumption for companies both with and without generators, but it's very different in terms of how it happens. Companies with generators, they only curtail during the curtailment hours, usually 4 p.m. to 8 p.m. Without generators, they have to curtail the entire day of the curtailment notice. Also, the reduction is quite different. It's almost double with generators when you don't have generators. What this tells us is if you make it easy for organizations to curtail, they will do it more and they will do it very specifically. So this is one of the key takeaways for the baseline AI effect. So significant effect, and if you make it easy, they will comply. Now, can we improve this effect with advanced AI? And why do we need advanced AI? And what do I mean by advanced AI? So I'm showing you a little snapshot of the data. This is temperature, scatter plot of the temperature and energy demand. A couple of things you'll notice. It's a complex relationship. It's nonlinear. It's asymmetric. But also, one thing you don't observe here is time dependency. There's time dependency in the data as well. So these things make it very challenging for us to do long range out of sample forecasting. And as I've mentioned in the beginning, our goal is to do 24-hour ahead forecasting at the hourly frequency. And for that, we're going to, just like Yiting's presentation, we're going to do a neural network model, neural network time series model to be more specific. I'm going to spare you the technical details, but I want to give you the intuition behind this. So neural networks essentially mimic the human brain. Just like we learn, looking at our environment, observing the changes in our environment and adjusting our behavior. Neural networks also learn from the data, that input layer there. They assess all of the information coming from the data, and their goal is to understand the complex relationships between variables, different ranges of the variables and different interactions hidden in the data. They absorb and process those interactions and identify those complex relationships in the hidden layer. In our case, we only needed one hidden layer, but you could add more hidden layers if the data is more complex and you have more variables. Ultimately, all of that information is passed into the output layer. For us, the output is the prediction of the energy demand. And I'll show you what it accomplished at the end. So we've been able to improve the prediction accuracy significantly. How much? It was about 98% accuracy out of sample, 24 hours ahead hourly prediction. But more important than that, we were able to predict peaks accurately. So you see on this graph the neural network model as well as the benchmarks, which are industry superstars and models that we've taken from the forecasting journals in the scientific literature. Almost entirely, all of them, they were able to predict 5 peaks in the intervention period. NNTS, the proposed model, was able to predict 9 peaks. And I'll show you the effect of that improvement in the prediction of peaks. So we're going to compare now what we've done in the intervention period, the 2022, which is the right panel, to what the partner company has been doing or had been doing previously. I'll use 2021, the previous pre-intervention data as an example. In 2021, they sent out 18 curtailment notices. We sent out only 9. They missed one of the 5 peaks with 18 notices. We got all of the 5. So what this tells us is we sent out fewer curtailment notices, and we made them, each of them, more effective. How much more effective? 50% reduction in curtailment calls, 71% reduction in number of false alarms, and 100% accuracy in 24-hour ahead peak prediction. This brings me to the nudging portion. And I'll show you the overall design of what we've done in the nudging section. This is essentially a year-long, longitudinal year-long field experiment. So we had 39 locations originally. We split them into a control group and a treatment group. And we used the matching design because of the limited sample size. So we used organizational characteristics for matching whether they have generators, their industries, the size of those locations, to split the companies into control and experiment. Before I move into the details about the nudges, I want to bring your attention to a couple of things which are important. The first one is everyone here, all 39 locations, they are intrinsically motivated to curtail because they pay to these energy consulting companies to give them advice, which is, making it very difficult for us because control group is also motivated to curtail. So we were very unsure whether we would see any results with the nudging. Second, also supporting that same uncertainty, is everyone here, all 39 locations, they were pre-trained in terms of how to curtail. So they know what to do, and they want to do it, all of them. So, making it even more difficult for us to see any results with the nudges. What does the nudge look like? We used a theory from the behavioral literature called planning prompts, and I'll explain what it is. So the left side here is an example of a control group curtailment notice. We didn't create this one. We used the partner's previous process, and we used their 2021 curtailment emails for our control group. It goes to the clients with this subject line of the email, Class A bulletin, daily bulletin, and then the date of the email. Our version, the experimental version, looks a little different. Also, the subject line is different. We say, curtail call today, the date, but we also put the time of the curtailment window, 4 p.m. to 8 p.m. What are the other differences? Planning prompts say that you have to tell them what to do, when to do, and how to do it. They already know what to do, it's curtailment. In the control email, there is a portion of the email, kind of hidden, but it's there, it's bolded. They show them when to do it, 4 to 8 p.m. Ours is a lot more salient in the experimental email. When to do it there in the subject line, it's there at the top of the email, as well as in a red box with an image to attract more attention of whoever is reading it. And planning prompts say you have to tell them how to do it. In the control email, there's no mention of how to do it, although the clients are trained, so they know how to do it. But we still put it in the email. We put something that they already know in the email just to make it more salient, more top of mind. And did it work? It worked. So I'm going to show you the control versus experimented, and I'll show you a robustness test as well. So we showed a 17.56% decrease in peak energy demand between treatment and the control group. But more exciting than this, so we were happy with this, but we were happier when we were able to show that this effect sustained over 9 repeated exposures. And this is a huge finding in the nudging literature. There's no evidence in the nudging literature of repeated exposure and long-term behavioral change, let alone in the organizational setting. So across over 75 days, over 9 exposures, this effect was there. So we're talking about long-term behavioral change. Now, one might wonder whether any of these effects are driven by how we design this matching process. So maybe something about the experimental group was driving these results. For that, and it's a valid question, for that we wanted to check whether anything in the experimental group has changed compared to the pre-intervention period. So comparing pre-intervention versus the intervention period only in the experimental group, the results are consistent. Almost the same reduction we show in the experimental group only, pre-intervention versus intervention, 17% roughly, as in the previous slide. So these are robust results. I'm going to finish by talking about our impact. I've already shown you some numbers. So let's talk about transportability. Where can we apply this framework? We can apply this framework broadly in any context where someone's managing, a supplier is managing scarce resources. What are some of those? And this is not a comprehensive list by any means, but some of the relevant and important ones for society right now, we were able to identify anything that ranges from freshwater resources to natural gas, waste management. In a city, if you're trying to manage traffic, road infrastructure would fall under this application framework, as well as telecom data. So anything that relies on scarce resources, we can use this framework for or intervention for improvement in demand, managing demand. So impact now, I'll discuss the impact for each stakeholder individually. I'm going to start with the partner company. And this orange bar, and I haven't shown this orange bar to you before, these are regular organizations in Ontario who don't work with energy consulting companies. So they are alone, struggling under a CPP structure, and they are trying to manage their electricity somewhat in a blind setting. So I call them regular organizations. It seems like their average hourly energy consumption during peaks is 1,400 units, kilowatt hours. Enpro accomplishes a 36% reduction for their clients. This is on average, with the AI plus BI framework, our intervention framework. What does it mean? So that 510 kilowatt hour difference, reduction in just 1 hour per organization, it equates to 22 days of household, 22 days of average household consumption of energy, just to put it in context. Now, let's move on to the organizations as the second stakeholder. What's the impact for them? We show them per year, they save $350,000. And I promised you I'm going to break it down. Here's the breakdown. 63% of that savings come from AI, but also a very substantial portion is coming from behavioral nudging. So this multidisciplinary framework accomplishes so much more than what we can do going with individual approaches. I think that really strengthens the potential impact of this framework. Now the environment, us and the regulators, what's the impact for us? So we started with per hour impact of the interventions per organization. Let's scale it up. Let's scale it up for Ontario, all of the Ontario. What's the impact? And scale it up for the entire country. What is the impact? If you scale it up for Ontario, it's 500 million kilowatt hours. I'm going to try to put it in context in a little bit. Stay with me, if you will. It equates to 30,000 households' daily energy consumption. This is per hour impact. And 2,000 tons reductions in carbon emissions. Entire country, 20 million kilowatt hours reduction in peak demand, 875,000 of households' daily energy consumption, and 9,000 tons of reduction in carbon emissions. What does it mean? I can't picture 9,000 tons. So I'm going to ask you a question. How many elephants does it equal to in terms of weight? This is just 1 hour impact. 2,700 elephants weight worth of reduction in carbon emissions in just 1 hour. Okay, so I'm going to finish up by reminding you about all of the stakeholders and saying that it's a win-win-win for all of us. This has been a difficult project to tackle, but we were able to show that it's impactful, it's scalable, it's transportable, but it's also promising because it brings together two very different approaches of science. Nudging, which looks at the behavioral dimensions of change, and advanced AI, which looks at very different notions when it comes to how we accomplish impact. Combining them, we were able to see a large impact. So again, thank you very much, and I'm open to questions.
Thank you very much. And now the judges will ask questions.
Hi, thank you. Such an interesting context. I just want to make sure I understand the context. So at the end of the year, the government looks at the 5 hours during the year with the most consumption, and then they penalize the firms for using during that time. And the company here is trying every day to predict whether tomorrow is going to be one of the highest days of the calendar year.
That's what we're doing during the intervention. They weren't looking at 24 hours ahead earlier. With the 24 hours ahead, they're able to give more time for organizations to act. So
it's just a unique and interesting context. So you show some very impressive reduction in emissions. To what extent are these actual reductions versus shifting the consumption to a different time? Because I think this is industry, they have to produce stuff. So are they just shifting consumption over days, or are they actually reducing the overall consumption of CO2?
So the CO2 emissions, and I learned it when I started the project as well, so this is really unbeknownst to most of us, CO2 emissions happen due to peak energy consumption. So when you shift your demand from the peak hours to regular hours, we are able to rely on green energy. So that's what we're looking at, shift from the peak to regular hours.
And so one more question, if you don't mind. So when I think of nudging, I think of maybe leveraging biases or heuristics. So here it seems the intervention gave people clearer information, maybe more information, like the hours of the day, and maybe like the layout was a bit more clear. So should I think of this as nudging or just more like clearer, cleaner communication? And if this is nudging, like what type of behavioral bias are you kind of relying upon in the nudging? Yeah.
I wish my behavioral colleagues were here. They would have been excellent in answering this question. So I'll answer based on my knowledge. This still falls under behavioral nudging, but we're relying on a theory called planning prompts. So you're nudging them by showing them how to do and when to do it in a more salient way. So really, we're not relying on biases as much, but we're relying on salience of these messages versus the not.
Thank you.
Okay. I have a question about also the behavioral nudging. So you mentioned that the experiment was done over 1 year. So my understanding is you send out like 9 emails during the whole duration of the year. Okay. So then for every single email, you have a different format.
Every single email, it's the same treatment, but the date changes or the hour of the curtailment notice change. But the email itself, the structure of it is identical. The only thing that changes is the day and the hour window of the curtailment time that's suggested.
Okay, I understand. Like in your case, is you have a very small sample size, right? So I think kind of splitting the organization into the control group and treatment group can be pretty challenging. You don't have a big sample size, and also, like you said, they all pay for this consulting firm to help them, right? And I also noticed that early on your slide, you showed they're from different industries, right? So I'm also curious, when you split the sample into treatment, control, how do you balance the different industries? But I noticed there are many, many different industries.
Excellent question. So we balance, so we have 39 locations, 9 industries. So we use industry as one of the components of the matching. The other one was the size of the location, their average energy consumption. The generators seems to be playing a big role. So generators and the existence of the generators was another big variable that we used. But because of that issue with the sample size, we still wanted to do the robustness check, and we were able to show this almost identical reduction across the 2 years with the experimental group. So that gave us some confidence about the robustness of the results.
Thank you. So does the company now use the behavior nudging, the treatment to all their clients?
Yes. Okay. So this was from 2022, and since then, they are still using the same experimental curtailment notice, and they are still using our computer program to predict the 24-hour ahead forecasts.
Maybe following up on this one, right? And of course, you had the consistent nudge in for one group versus the other one. Is there stickiness to it? Can you at some point stop? So you explain carefully how to do it. Do you have to repeat it every single time? Or, so once you find something that moves the needle in the organization, right, I then try to make it more efficient. Do you have the intuition, you haven't tested it, that you can at some point stop with doing that?
We haven't, and this is really of no cost to ANPRO either, so I don't know if there's any motivation to stop. But one concern could be, is it going to be as effective if this happens, or if you continue with the same similar type of nudging for the 2 or 3 years, and it's going to lose its effectiveness? So we could test that potentially, but because it works and because they save a lot of money, I'm hoping they will stick with the organizations as well.
Thank you so much.